So on proof tip 7, we're just going to revisit what we did yesterday when we proved the triangle, or the isosceles triangle theorem and the converse of the isosceles triangle theorem. Those proofs were the first time we actually were trying to prove a part equal to a part, like an angle equal to an angle or a side equal to a side. Before that, we were proving triangles congruent to triangles. Okay? And if you remember, what we did to do that is we first had to prove triangles congruent to triangles. And then we said, because the triangles are congruent, well, what does that mean? That means all the parts are congruent. And how many parts are in a triangle? 6 parts. And so I have up here, by definition of congruent triangles, we know that corresponding parts, and when I say that, I'm talking about all 6 parts in one triangle. So it's all 6 parts in one triangle correspond with 6 parts over here in another triangle. Like side A might go with side D over here, and so on. So corresponding parts of congruent triangles are congruent. So if we show 2 triangles congruent, so triangle, say ABC, is congruent to triangle DEF, then automatically what flows from that is we get 6 other congruent statements. Angle congruent, 3 angle congruent statements and 3 side congruent statements. And so that's what we're going to build off of. You see the title here is CPCTC, and that stands for, so C is your corresponding, P is the parts, we're skipping of, C is congruent, T for triangle, skip R, and C for congruent. So CPCTC stands for corresponding parts of congruent triangles congruent. Eventually, you're going to hear this so much, you're going to know what it means, and then I'm going to say we'll just write CPCTC. But what I don't want you to do is memorize CPCTC and have no idea what it means. Okay? So until you know exactly what that means, you're going to be writing that statement out. And there's a way to abbreviate some of those things, like for triangles, you could write a triangle. For congruent, you could do congruent statement. But if you don't want to write that out a lot, then learn quickly what that means, and then you can use CPCTC. But if I see you using CPCTC, then I can ask you. I can say, hey, I'll cover it up. What does that mean? You gotta be able to tell me, okay? All right. So let's take a look at number 1. So we have some givens, and we want to state a proof here. We're given that AB is congruent to DE. So this right here is congruent to this right here. And we have that CB is congruent to DF. And we have that C is a right angle. And we have that F is a right angle. And we want to prove that angle A is congruent to angle E. Okay. So we have 3, I mean, really, we have 3 parts already congruent to 3 parts. Okay. We don't have the part we want. We don't have A is congruent to E yet. And so the way we need to go about this is we need to say, okay, if I don't know that A is congruent to E, but I have those other 3 parts, can I say that the triangles are congruent by something like that we've studied already? If we can, then after I say the triangles are congruent, then I can go back and say, well, then all the parts are congruent. Okay. So we ask Cody, are those 2 triangles congruent? And by what? What theorem? Okay, isosceles triangle. Do you see an isosceles triangle? Okay, so actually the isosceles triangle theorem helps us get a part. When we talk about congruent triangles, you're going to choose from the 5, the angle, angle, side, angle, side, angle, side, angle, side, 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 or hypotenuse, like one of those. So, and if you don't see it yet, that's fine, just so you don't see it. But if you do see it, you see which one of those 5 would make those triangles congruent? Hypotenuse leg. Good. Because hypotenuse leg, if we want to use that, we need 3 things. We need a hypotenuse right here, congruent to hypotenuse. We need a leg congruent to leg. And just to be able to say hypotenuse, we need to know the right triangles, and they are. Okay. Good. Lindsay, what's the reason for statement 1? Given. Good job. That was a hard one, huh? Okay. Hope, can you help me fill out statement 2? Triangle ABC would be congruent to what triangle? E. What's the next letter? Careful, F is where the right angle is, and C is where the right angle is. So F and C need to be in the same spot. And we see that C is the last one. So you want to make sure F is the last one. So what would it be? EDF. Okay. And then Hope, why are they congruent? What did Cody say? Remember? It was and I wrote it here, hypotenuse leg. And so that's from step 1. All right. And then we want to finish this thing. And so Maddie, angle A is going to be congruent to which angle? Angle E. You know why? It's what our lesson's about. The corresponding parts of congruent triangles are congruent. Okay, so right now that's how you can abbreviate it. Once you know that statement and you're really good with it and you're not going to forget it, then you can transition to CPCTC. Okay, so I'll be writing both of them right now. Eventually, we're going to transition to that. Okay. For right now, let's do it. Just a few times. Do it at least for the first 5 times. Okay. So we're going to try that again. You want to try it with 3 or 4? 4? 4? Okay. So you guys need just a couple minutes to work ahead of me because I don't want to take the fun away from you. Really, you have to develop the skill of seeing congruent triangles. So don't write anything on the proof. I just want you to mark up the picture and try to see what path you're going to take, or see if you can see it through. What's congruent to what? You want to get congruent triangles somehow. See what you can come up with. Okay, so I gave you guys a little bit of thinking time, and I'm going to mark what's been given. AED is isosceles, and isosceles means something. The definition of isosceles means something. Alex, what does that tell us? What's congruent to what in our diagram because it's isosceles? So, do you know what isosceles means? If we say talk about an isosceles triangle, what do you know that's true about an isosceles triangle? 2 congruent sides. So which sides in here would be congruent? AE and ED, perfect. Okay. Then it says AB is perpendicular to BC, right here. You got a 90-degree angle there. And it says that DC is perpendicular to BC, there. Then it says E is the midpoint of BC. So, Elijah, how does that help us? Perfect. Okay. Before we get to congruent triangles, Can anybody see another part that's congruent to another part? All right, yeah, you're ready. What are you going to say? Oh, before you get there, don't talk about congruent triangles yet. I'm talking about congruent parts. There's one other, I think, Lindsay, I saw you next. Yeah. This angle is congruent to this angle. Why, Lindsay? One of the theorems that we studied last time we were together, and it's about isosceles triangle. Do you know what it's called? Is it the isosceles triangle theorem or the converse? If you start with the legs, if you start with the isosceles triangle, then it's the isosceles triangle theorem. That gives you the base angles. If you start with the angles and you want to find that it's the isosceles triangle theorem, kind of going backwards, it's the converse. Okay, so I just wanted to point that out, since always look for that. When you have an isosceles triangle, think, okay, congruent angles at the base. We may not need all that stuff, and in this one we didn't need it, but I just wanted to point it out to you, okay? So we wanted to get these triangles congruent. Don, do you see why those why any two triangles in here might be congruent? Hypotenuse leg. And which two triangles are we looking at? Okay, these two. Good. By hypotenuse leg. And so when we start our proof, we start with the given. So let's write that out. So we got an isosceles triangle AED. We have AB perpendicular to BC and DC perpendicular to BC. DC perpendicular to BC, is that right? Why didn't it say Marvel? Why does it have to say DC? All right. And it says midpoints of BC. Okay. And that's given. That's how we start it. And we got to take it from there. And there's a little bit of freedom. But what has to happen before we get to our last statement? Because this one's going to come with our corresponding parts of congruent triangles are congruent. But in order to use that, you have to say that triangles are congruent. You cannot use CPCTC if you have not shown triangles congruent. So that always comes after congruent triangles. So we need to go for congruent triangles by hypotenuse leg. To show hypotenuse leg, you got to show a hypotenuse congruent to hypotenuse, a leg congruent to a leg. Sorry, should be an L. Leg congruent to leg. And just to be able to say hypotenuse, you need to show that they're right triangles. So 2 right angles would be enough for that. And we don't have any of that on this proof. So we have to show those things first, and then we got to get congruent triangles, and then we can use our corresponding parts of congruent triangles. Okay. And so that's going to be the flow of our proof here. So, Alyssa, can you give me a statement that would help us in proving congruent triangles? Before that, we can't say that yet. We have to show these things in our proof. So you could either go with hypotenuse, or you can go with leg, or you can go with the right angles. Just give me one of those, because you're jumping too quickly. We don't know that. We know it in the picture, but we have to put it in here. So can you give me a part that's congruent to a part? Good. EA is congruent to, what'd you say? I don't know about that one. So EA is this This one, CD is that one right there. Oh, you said BA. We don't know that yet. That's what we're trying to prove. What's something we marked on our picture? Look at our picture. Look what we've marked. Let's go with the EA. I said EA. EA is congruent to what, Alyssa? There you go. Thank you. And there's a reason for that. You know the reason for that? Where did that come from? When we mark that up on our picture, how do we know that EA is congruent to ED? What in statement 1 tells us that? The isosceles, yes. So what reason would we give? And there's 3 options. I'll give you the 3 options. Isosceles triangle theorem, converse of isosceles triangle theorem, or definition of isosceles. Which one seems best? So the isosceles triangle theorem would do this. If you have isosceles, then your base angles are the same. So that we're not wanting that. The converse says if you have base angles the same, then it's isosceles. The definition says if it says isosceles, that means 2 sides are congruent. We want the definition. The definition of isosceles triangle. Good. All right, number 3, we're working towards proving the triangle's congruent, but we need some more pieces in order to do that. Rowena, can you give me another piece? Good. Do you know why? Perfect. Okay. So we have established hypotenuse congruent to hypotenuse, leg congruent to leg. We can't show hypotenuse leg yet because we haven't really shown that they're right triangles yet. And so we need a statement about that. And so, Natalie, what should we write for the statement? Let's go angle. Angle ABE. And that's true. But before we could say well, why would you say they're congruent? Let's go there. You're right. Okay, so we first have to establish that they're right angles. So let's do that. Angle ABE and angle ECD are right angles. Do you remember, or do you have an idea why? Definition of perpendicular. Good job. And from there we could say that they're congruent to each other, and the reason would be all right angles are congruent, but we don't need that. Because for hypotenuse leg, if you just get this far, that's enough. So statement 2 is your hypotenuse, this is your leg, and this is saying they're right triangles, and now we're ready to say the triangles are congruent. Statement 5. Tyler? What triangle is going to be congruent to what triangle? You can look at your paper too if you need. Yep. And why? Good. And I just noticed I'm not putting the steps on yet, so let's do that real quick. So hypotenuse leg is shown in steps 2, 3, and 4. And 2, 3, and 4 rely on step 1. Okay, are we done, guys? Almost. Okay. Suzuka, finish it off for us. What's our last statement? Good. And why? Yep. And abbreviated even more would be CPCTC. And we got our proof. All right. Turn to the next section. Level 8, overlapping triangles. So this is the hardest one. Well, this is a harder one to see when triangles overlap. Okay. But when triangles overlap, what's important for you to look for, okay, so me teaching, what I can teach you is this. When you have triangles that are overlapping, you're either looking for a shared side or a shared angle. It's going to be one or the other. And you want to locate that because that's going to be key in your proof. If we have a shared side, like if we had this, like BD here is shared between two triangles, and we said BD is congruent to BD, what was our reason? Reflexive property of congruence. So if you have a shared angle, you can use the same property, reflexive property of congruence. We haven't done it yet, but here's where it'll start to come up. So if ever you want to say an angle is congruent to itself, the reason's the same as a side congruent to itself, reflexive property of congruence. So in this picture here on number 1, we have DB is congruent to DC. So there is your right angle. We have BC is congruent to AE. We have, did I say congruent or perpendicular? I meant perpendicular. We have DB is congruent to BE. And we want to prove that angle A is congruent to angle C. Now, just by looking at what we're trying to prove, hey, that's a part congruent to a part. So we're probably going to have to use the CPCTC, which means that we're probably going to have to show two triangles congruent. Okay. If you look in here, you should be able to see 4 triangles. And so we have to have some sense of, well, which 2 triangles should I show? And they're overlapping. My clue to you was when it's overlapping, look for what's shared. Is there a shared angle or a shared side? Which angle is shared? Angle B. Okay. And another technique, if you have something like this where the angle's shared, you don't have to do this. If you're good at visualizing, you do not have to do this. But if you're like, man, that's a little confusing, separate the triangles. So I'm going to separate them for you. So I'm going to draw AE, the big ones. So AEB, okay. And then the other big one that I think might be congruent to is the something. It doesn't matter the positioning, but so B, D, C, and I'm going to mark what I know. I know this is 90. This is 90. I know that this is congruent to this. And I know that angle B is congruent to itself. So I need to put that on both of those. Once you separate them, then it's much easier to see why they're congruent. Right? In that mess, you might not see it. But once you separate them, can everybody see why they're congruent? Angle, side, angle. So that's another trick. If they're overlapping, you can always separate them like that. But be careful when you separate them. Whatever they were sharing, make sure you say they're congruent to that. Okay, angle B is congruent to angle B. Okay. So now that we have this, let's write this proof. Donovan, what's the reason for number 1? Good job. Okay, so we have all our givens. We wrote them down. And then number 2, angle BDC and angle BEA doesn't look like it's finished yet. So you have to know where it's going. We got to finish that statement on number 2, and then we got to give a reason for it. Okay. So Ty, do you know how to finish that statement where it's headed? Perfect. Right angles. Do you know why? Good job. Okay. 3's still not finished either. We got to finish that statement and then have a reason for it as well. Leah, how would we finish that statement? Angle BDC is going to be congruent to which angle? BEA. Good. And do you know why? And that's good. Looking back is fine. Notice that they're both right angles. There you go. All right angles are congruent. Good job. Okay, then statement 4 is not there, but you see the reason, reflexive property of congruence. Mac, what do you think? Oh, sorry, angle B is congruent to angle B. So, guys, homework is to finish, work through these and finish the 7 and 8, okay? Have a good weekend. 7 and 8.